All right, we're back. We are still on page 92 of math analysis, and we are trying to get to the 14 formulas, and we're up to 5. We have Euler's formula, we have the sum and difference formula for sine, sum and difference formula for cosine. That's 5. Hopefully you have them memorized, or at least you're working on it, because they're all based on each other. So the next thing we're going to do is we're going to come up with what are called the double angle formulas, because you're doubling the angle. Whatever angle I give you, you're going to double it and find the sine of that or the cosine of that. The way we do it is actually pretty straightforward. We're going to start with our formula for sine of a plus b, right? So that we know is going to be sine of a cosine of b plus cosine of a sine of b. So this is one of those things, if you don't know it, I don't know how you're doing it, but once you know it, you can use it in any way you want. And now what we'll do is we're going to replace b with a. So just let every b that you see become an a. So sine of a plus a is going to be sine a cosine a plus cosine a sine a. But if you look at it, because it's multiplication, let me get a good highlighter. This and this are exactly the same, right? They're both sine times cosine. So what I'm going to do is I'm going to write the sine of a plus a is 2a is 2 times, for some reason you start with sine on this, I'm not really sure why, but 2 sine a cosine a, and that's it. That's the double angle formula for sine. So sine of 2a is 2 sine a cosine a. Let's put that down. 2 sine a cosine a. All right. So that, and we're going to memorize that. Now, cosine. Cosine's a little different. So we're going to do the same idea, though. Cosine of a plus b is cosine a cosine b minus, because it alternates, sine a sine b. Now replace every b that you see with an a, and we'll get the cosine of a plus a is cosine a cosine a, which is cosine squared of a, and then minus sine a sine a, which is sine squared of a. So look what happened. We got something, so this one's dangerous though, because it looks an awful lot like the Pythagorean identity. That minus sign makes all the difference, right? If this was cosine squared plus sine squared, which is equal 1, but why would the cosine of 2a always equal 1? Like, why would that be a thing? I mean, I can't imagine a scenario. So this is one of our formulas. Cosine squared minus, look at me being all inconsistent with parentheses. Nice. Cosine squared minus sine squared. All right, so what are we up to? 6, 7, I think. But because of the fact that, here, I'm gonna have to duplicate because I don't want to handwrite it again. Duplicate and come over here. All right, so because we know that cosine squared from the Pythagorean identity is 1 minus sine squared, we can also say that the cosine of 2a equals, so what we're doing is we're looking at this and we're going to replace it with 1 minus sine squared, right? That's a fundamental identity, and then minus another sine squared. So let me just highlight to clarify what happened. So we replaced the cosine squared with 1 minus sine squared, which means the cosine of 2a can also be rewritten as 1 minus 2 sine squared of a. So let's put that in the box. So 1 minus 2 sine squared of a. So this formula will become more important as you learn more and more calculus. And then I'm going to duplicate it again, and you can probably guess what I'm going to do. I'm going to replace the other one. So here, I'm going to look at this and say, I know what sine squared equals. So sine squared is 1 minus cosine squared. So we're going to say that the cosine of 2a is cosine squared minus the quantity 1 minus, so those parentheses are really important. We get this, So we could also say, so just to clarify, we replaced sine squared with 1 minus cosine squared, which you can always do. Sometimes it helps, sometimes it doesn't, but you can always do it. Here we have cosine 2a is 2 cosine squared of a minus 1. All right, that's another form. Cosine of 2a has 3 different forms. I would say that the ones that have the 2 in them, 1 minus 2 sine squared and 2 cosine squared minus 1, are like, they're the ones that come up. The cosine squared minus sine squared, I mean, yeah, it's a thing. But in my experience, you use these a lot. So the way you actually end up using them, which isn't like, it's not super important to us right now, but you use them in what's called a power reducing way. So for example, because cosine of 2a equals 1 minus 2 sine squared of a, and you can work this out. You can work out that sine squared of a is equal to 1 minus 2, what am I doing? Oh, 1 minus cosine of 2a. That's what I'm doing. My brain all of a sudden was like, where are we? You can also work out, so just do it, like go through and solve them. Cosine squared of a, why am I so small? Equals, that's a weird a when you zoom in on it, is 1 plus cosine of 2a over 2. You will use these in calculus all the time to take you from a squared down to a linear power of cosine, so a first degree, because it's just easier to work with. So double angle formulas for cosine, super important. Double angle for sine, also super important. These are key. So I don't know what we're up to. I think we're at 5, 6, 7, 8, possibly 9 are we at? Maybe. So I'm going to end this video here, though. Also, I'm just going to scroll up and see. We had 3 on the first page, 4, 5, and then 6, 7, 8, 9. I think we're at 9, right? So we got 5 to go, and that's pretty good. So I'll be back in the next video where we're just going to keep doing more of these. So see you there.